What we're looking at now is something called the fetch execute cycle, and this is a really important thing within the CPU, the central processing unit, and it consists of three simple steps. It's got three simple steps in it. The first one, obviously, which the name would suggest, is the fetch step, and what this is doing is it's retrieving or it's getting an instruction from memory. So that's RAM. And it's also doing something else. There's a thing inside the CPU which is called a program counter. And this will be incremented, so that means we'll add 1 to it. So if the current program counter is storing that we're in 53, so the part of the program we're running is in memory location 53, we're going to increment that to 54. So we'll add 1 to it. The second step is called the decode step. And what we're doing here is we're decoding an instruction, also known as an opcode, operation code, and its operands for the different areas of the CPU. Now this word operand you might not know, it might sound difficult, so let's look at what it means because it's really, really easy. If I take the sum 5 plus 7, what I have here is the 5 and the 7 are the operands, and these feed into the plus, which is the operator. So this would be written in assembly, for example, as add 5 and 7. And so here we've got the operands, and here we've got our opcode or our instruction. The third and final step which we have to do, so fetch decode, it's the fetch execute cycle, so fetch decode and execute. And what we're doing in execute is we're connecting up all the areas of the CPU, first of all, and then we're performing or doing the operation. And that's all that's happening over and over again. We're taking an instruction out of memory, we're decoding what it means, and then we're executing that instruction. Now, me doing it with a load of words is possibly not going to be so easy to understand, so let's have a little look at a diagram. And here we go, we've got the CPU on the left, and we've got our RAM on the right. And if we then take a look, we've got our program counter, which is going to store where we are in the program, and we've got our memory locations down here. Now let's put some numbers in there. So our program counter is currently storing that we're currently on number 5 memory location. That's where we'll find the next program instruction, is in number 5. We've also got some other things in here, so let's take a look at what those things are. We've got something called an ALU here, and that is an arithmetic logic unit. And that's doing our arithmetic for us, so it will do addition, subtraction, multiplication, division, that type of thing. And we've also got these things up here called registers, and these are small areas of memory on the CPU. And these are really small, so even on a 64-bit processor, it's only going to be 64 bits. And so it's just there to store one number, just like the program counter will store one number. And so what's going to happen when this thing runs? So currently I've got 7 in the register 1, I've got 5 in register 2, and there's probably a handful of registers, maybe 4, maybe 8, something like that. And so when I run this program, what's going to happen is it will first look to the program counter and it will say, oh, right, the program counter's saying 5. So I will find my next instruction over here in memory location 5. And that instruction is 110 10010. Now, I've just made that up, but in real life, the computer would then, on the processor, it would know exactly what that instruction meant. So I'm going to tell you that in this case, that instruction means add register 1 to register 2. So that is my decode phase. It's decoding that this binary here means add register 1 to register 2. So I've done stage 1, which is fetching my instruction. I've then decoded it as step 2. So 1, fetch the instruction. 2, decode the instruction. And then I've got my 7, I've got my 5, and so I now need to execute that instruction. So I'm going to connect it up, I'm going to put these into the ALU, and I'm going to execute that instruction. And so I'm going to say add register 1 to register 2, and then it will pop it back into register 1. So it comes around here, and instead of having 7 in there, I will now have 12, which is the result of 7 plus 5. And that's all that's happening within my fetch execute cycle. I'm going here, seeing that it's 5, so I'm fetching my instruction from memory location 5. I'm then decoding that it means add register 1, register 2, and then I'm executing that instruction, so I'm connecting it all up, putting it into the ALU, executing it so that it ends up with 12 in register 1. Or whatever the instruction might be. There's probably 50, maybe 100 different instructions the processor could be doing.